All right, we do it again. So we're going to get our axis of symmetry by doing x equals negative b over 2a. So remember, this is in the form ax squared plus bx plus c. So my a is this 1 that we're too lazy to write. The b is a negative 2. The c is a negative 3. So x equals negative b over 2a becomes x equals negative 2 over 2 times 1. So 2 over 2, which is 1. So my axis of symmetry is x equals 1. For my vertex, I know my axis of symmetry, my vertex is on the axis of symmetry. It's that point right there where it's symmetric. So if I've got the x value, I've got this formula, right, that tells me what the y value is. So just plug it in. When x is 1, the y will be 1 squared minus 2 times 1 minus 3. So it'll be 1 minus 2 minus 3 is negative 4. So when x is 1, the y is negative 4, and that's my vertex. If I'd like, I can plot this as I go. My axis of symmetry is x equals 1. My vertex is 1, negative 1, 2, 3, 4 down there. And then I can keep going. I can get a y-intercept always by making the x equal 0. So when x is 0, I'll have 0 squared minus 2 times 0 minus 3. So 0 minus 0 minus 3 is just negative 3. Some teachers have taught just pluck out the c, which is true, but it can get you in trouble sometimes if it's in a different form. And this works for all graphs, so no need to memorize silly shortcuts. So my y-intercept is 0, negative 3 down there. I can plot another point on the other side of my axis of symmetry for free. My x-intercepts, I can't see them right now, so we'll actually have to do the work to do it. So an x-intercept, again, always happens, no matter what graph you're looking at, when the y is 0. So make that y equal 0 and solve whatever comes out of this, right? It is a quadratic because the highest power is a 2. And so your first thought is maybe it factors. That's fastest. But if you're like, no, I don't like factoring, or if it doesn't factor, you've got quadratic formula. So I'm going to try to factor it. I'm going to do multiply to make a negative 3, add to negative 2. That'll work. A negative 3 and a 1 will multiply to negative 3 and add to negative 2. So a negative 3 and a 1 is how this will factor. If you need to check it, you can check it with the rainbow rule distributing. If you FOIL this, expand this back out, you will get that. So, and there's more practice we could do on factoring, but we'll leave it at that for now. And so the beauty of factoring is if this times this equals 0, then either this equals 0 or that equals 0. So x will be a 3 if you add 3 over, or x will be a negative 1. So your x-intercepts, if I put them in ordered pair form, x is 3 when y is 0, and x is negative 1 when y is 0. So I can plot those, 3, 0, negative 1, 0. I'm a little concerned because I'm 3 away and 2 away. So it should have been symmetric, and it's not. Oh, because I can't plot. This is 1, 2, 3. Okay, phew, we're good. So now everything is still nice and symmetric. We're good. And all I need to do is sketch. Now I've got enough points plotted here to sketch, and that's fine by me. There's plenty of points in there. I don't think you need any more. If you needed more, you could always make a little XY chart and plug in any points you want to get more, any X value you want to get more points. Just for fun, if you don't like factoring, I'll go ahead and do quadratic formula for this just to show you get the same y-intercepts. because if you're not fast at factoring and need to do this, some people prefer this. But factoring, do practice factoring. It is useful for sure. So if I do negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, I get underneath that radical, it's 4 minus, the minus will make a plus, and that's 12, so 4 plus 12 is 16, the square root of 16 is 4. So I've got 2 plus or minus 4 all over 2. So if it's 2 plus 4, that's 6 over 2. If it's 2 minus 4, that's negative 2 over 2. So 3, negative 1. So matching what we got. Oh, isn't math beautiful? Yay.